Ooh, hey everybody, this is Larry. This is 17th of February. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, other problems, I don't know, whatever. And also, I do these live, so if it's a little bit slow, let me know. And today's problem is container with most water. Okay. And you cannot slant the container. I guess this, I do like problems of photos because then I think the understanding is just a lot easier. Okay. Okay, so the thing that I would think about is reducing this problem a little bit, and the second thing that I think about is just n, because there's a. My first thought is that okay, if n is small enough, we can just do n squared, right? But because n is equal to 3 times 10 to the fourth, well, you're gonna have to do something faster than n squared. And then the second thing, or the first thing, which I said, is kind of try to reduce this problem in a way of asking the right question, right? And then the question here for me is, and you can ask this in either directions. I think it should be the same. I could be wrong. But, and I think there's possibly a molecule, but the way that I would think about it is just asking the right question of, okay, so given that we are at one vertical point or one vertical slant, how much water what is the most water that this line can hold if this is the right endpoint, right? And then, okay, so that's my first question I would ask, is that, for example, here, on the, just pick any random line and then ask, okay, if this is the right most line, what is the most water that you can get, right? And the most water that you can get is, in this case, and maybe we have to do it both ways, but it seems like in this case it would be the leftmost vertical line that is bigger than this line, right? That is higher than this line. Okay, so I think that's the kind of the recurrence that I would, or invariant that I would think about. And there's some symmetry thing where you can just do it to the other side as well if you need to. But that's kind of my general first impression. Okay, and then the question is, okay, now let's say we have that query that we have to do for each line. How do we do it in an efficient way, right? So let me write this down real quick. So for each vertical line, what is okay? Well, there are two things, right? Assuming this is the right partition, what is the best corresponding left partition, right? Or like the left vertical line, right? And for that, again, we say that means that so let's write. Okay, so here's what I'm going to do. I think I'm going to write the naive algorithm first, and then we'll talk about how to optimize it, right? So we do a for right in range of n. Let's say n is equal to the length of heights, and then the naive way, which is what we talked about earlier with the n square way, would be just for left is in range sub, right, maybe right -1, and then now we try to get something like if left or height of left is greater than or equal to height of right, then the area is equal to right minus left, maybe +1 or something like that, but roughly speaking, times the min of the heights, which is just heights times right? So something like that is the area. So now, okay, so this is clearly going to be n squared because we have two loops and it's n, right? So how do we optimize this? It turns out, that So now what I'm thinking is just thinking about, okay, what are things we can do, right? Well, maybe we could play around with just keeping track of the max, but then that doesn't work, right? Because you can have something like let's say you have something like let's say you have something like, maybe I could draw lines, but you have a 2 and a 5 and a 3, and then here let's say you have a 1, and when you're processing the 1, you actually want to connect with the 2 and not the 5, right? So you have to kind of get, given all these numbers, get the leftmost. And I think for me, the first, and there may be a monoq thing somewhere, but I don't like solving things with monoq. Mostly because it forces you to make sure about an invariant, which maybe is helpful, or it'll definitely be helpful if you think about linear time, if that is necessary or if it's possible. But for me, it's about solving the problem first, and the first thing that I'm going to go to try will be n log n, right? And here, I think it's sufficient to use a sort of well, for me, I'm going to use a sorted list. It depends on your language and library and stuff like that. But the thing that I'm thinking about is, so basically we have a sorted list, and we add in one at a time, so that when we get a 1, we can but just binary search the rest of the list because it's in sorted order, and then try to find the one that is the left. Wait, does that work? Maybe that doesn't work. Give me a second. Let me think about that. That doesn't make sense. I think I've been defaulting to that a little bit. So I don't think that makes sense, because if it's sorted in 2, 3, 5, but then you have to get the leftmost of these things, which could be the 3 as well. It doesn't have to be the smallest or anything like that. So that is definitely a little bit awkward. And there are things you can do to do that, but I'm trying to keep things about elementary. So this is a hard problem, at least for me. So let me think about this for a second, about how to solve this, because I don't have an immediate problem, which is the first time in a couple of weeks for these things. I would also be honest that I've definitely solved something like this before. Okay, so I think for these then, it's just trying to think about an invariant about this. And in this case, what is the invariant, right? The thing that I'm thinking about here is there are really only 4 scenarios, and we can try to think about them, which is okay. So before we have like or we can even just take the input from here as an example. So the kind of the scenarios that I'm thinking about, just like 1, 8, and then and then now you have to process in order 6 and 2, and then the other one is maybe the other combination, 6, 2, and then 1, 8, 2, 6, and then 8, 1, 2, 6, right? So those are kind of like the combination of orders of which I'm trying to think about in terms of invariance, and whether we can use either monoq or monostack or something like that. I'm really bad at those. But okay, so I think one thing that I would think about is that, okay, and this is just about exploring the properties of the numbers, but let's say we have at least the 8-1 scenario, which is kind of in the 8, 6, and 2 scenario, right? Because basically my idea is that, okay, if you have an 8 and then you have a 6 and then you have a 2, there's a sort of greedy algorithms here, right? Because if you let's say you have a 4, it never makes sense to match a 2, even if this answer could be 1, and the best answer is going to be an 8. If this answer is a 2, the best answer is still going to be an 8, and so forth, right? 3, 4, 5, 6, 7, 10, all the way up to I mean, maybe in this case, it just doesn't go through, but all the way up to 8, then that 8 is going to be the best answer, right? So in that case, we can keep track of, I'm thinking about, in that way, how do I express this? That when you get a new number, if it's smaller than the max, you just don't care about it, right? So in this case, you can collapse the 6 and the 2 because the invariant is that given that the previous best answer is 8, it's never going to be, like the 6 and the 2 will never be the best answer. I'm going to denote that with a star, right? Okay, so that's one case where you have decreasing, right? What happens if you have increasing? So you have 1, let's say you have 1, 5, and 8. Well, this one's a little bit tricky, right? Because later on, let's say you have the number 4. Well, the number 4, you want to be able to get the number 5, right? And if you have 4 and then 6, then the 6 will match to the 8, the 4 will match to the 5, and so forth. So I don't know if there's any consistency here. And I think the thing that I would think about right now is whether I'm asking the right questions, because it seems clearly that I'm a little bit off for this one, and I'm already 10 minutes in. If we well, we ask the queries in this order, then you could kind of get a reverse stack, but that's not a generalized thing, right? So for I feel like let me think for a second. I feel like there's a binary search E thing, but so the 4 would go to the 8. You calculate the area from that, but then the best answer would be a 5 in this case. The 6 would and then the 4 gets thrown away, but the 6 would definitely match with 8 instead. How do we match the 4? And maybe a more example is, how do we match the 1 with the 8, right? So let's say we have 1 and then a 10. Later words, we want to compress the 10 here, but we still want to process the 1 to a 5, right? And this can also go in a number of ways, right? So so it could go 1, 6, and then 4. And in this case, the 1 would match the 1, the 6 would match the 8, and the 4 would match the 4 ideally, or the 5 ideally, right? Man, I really need to get more sleep before doing these. I'm struggling a little bit with this one, which happens from time to time. But, it might be that I'm asking the wrong question for this one. Let me look at the problem for a second. And also there's tie, so 8 and 8. Can I do a binary search another way? I mean, you could do a binary search on the binary index tree, but I don't really, or segment tree or something like that. But I don't really. I think like there's an easier way to do that. Wow, I think I might have also been mixing this with another problem with rainwater or something. I think I feel like and yeah, and this will always have to be in this order. Can I just binary search now then? because we know that the previous things will always be in increasing order. I think before we were doing an example where that's not the case, because we were doing like, okay, there's 518 where, you know, but given the premise of what we just talked about, then it would always be in increasing order. And now that it's in increasing order, we can just do a binary search on it. I think that works. I don't know that that's the optimal solution, but I think that works. So let's give it a try. Because I think, you know, I like to give it a try and, you know, learn things as well. Yeah, and then we just keep on pushing the max things on top, and then we could binary search on it. Okay. Yeah, okay. Let's give it a try. I don't know if this is going to be correct, to be honest. But I feel like this is correct, but because there's a greedy component, sometimes I might miss a case. But as I said, I think there are only 4 possibilities that I would consider some configuration, and I think we considered it all here. So I think I'm on the algorithms. I feel like I'm going to be right. It's going to be n log n. And these are things that I think about before I implement. Sometimes I don't say it in this order, but I think about the complexity, and I know that it's going to be n log n, and given n log n, it's going to be okay, right? Or maybe call it maxis. Yeah. So now we processed from right to left. So what happens to right to left? Well, for right to left, we have to go. We have to find the leftmost number that is bigger than this, right? So, so I think we can just do a bisect left on max, because now this gets the insertion point for this point. I think bisect. Yeah, we want the bisect left. Index is equal to index left. If index is greater than or equal to the length of max s, then that means that this is the biggest number. So then we just append heights of index or heights of right, and this is actually else we can calculate the area, and then we'll just do the best. So best area is equal to 0. Otherwise, area is equal to, as we said. So the we actually want to. Man, I am missing a lot of things here. We actually want to also append the index of the thing that we're adding. So we only add things to the maxes if it is the biggest number, and then we add the index of that number. So then the area would be the maxes of index of the second character. So this is the index, and then this is the yeah. So that's the index of the other one minus right. Or actually, I guess it's the other way. It's right minus this, and then it's this times the height, which is going to be heights of the right. All right. So this is not going to be right yet, but it's, because we only do it from one direction, so we have to reverse this and do it in the other direction as well. But I'm going to give it a run just to kind of see whether we're okay. Did I misspell something? Is it heights or heights? I'm going to heights seems like a more sensible variable name anyway. So yeah, so this gives us the right answer for this. Is obviously, like I said, it's not. I'm not going to be confident, and I don't think. I mean, well, I'm not confident because I know it's not going to be right. Because we don't do the symmetry the other direction. But let me at least put in the other test cases and test that out. But the thing is, it may be right by accident, and I would think about coming up with an example case. For example, this in reverse should be a wrong answer. For example, 3845261. See? So, okay. So the way that we do it in reverse, I'm just going to cheese it. Sometimes I don't, but this time I am. I'm going to just change this to a function of define get sweep max area or something like that. I don't know. Heights, right? And then now we can just return max of, put this in here, max of get sweep max area of heights, and also do the same but in reverse. Something like that, right? It looks good. Let's double check for like fewer. I guess it already did the fewer items, and it did. Let's try 110, 10, 1, and should still get the right answer in both cases. Obviously, because if it doesn't, then we don't have the right answer. Let's give it a submit and give it a go. Even if this is right, we'll take a look at. I suspect there's a linear time. Yeah, so this is accepted. So I hope that you learned something by seeing me grind, because this was a tough one for me for sure, and you kind of see my thought process as I go through it. But that said, this is not even the optimal. I suspect this is not the optimal answer. I did it with this thing, but I think I wonder if there's a property so that I don't have to do a bisection. So what is the complexity, right? Well, we call this thing twice, so it's going to be the complexity of this thing. And here we have a for loop that's O of n, and for each of the for loop we do a bisection. So that's going to be n log n in the worst case. So we do 2 n log n cos, and each of these can contain O of n space as well. So that's going to be our complexity for the current algorithm. But like I said, I suspect there's a linear time algorithm. So let's kind of look at the hints and see if we can figure out hints. Maximize might not be the maximum size. This is a very drawn out hint, but start with the maximum width container and go to a shorter width container. If this way it comes. Start with the maximum width container and then go to short. If there's a vertical. I guess. Is this like some kind of... I mean, this is too big, right? 30,000 for n square. I don't know. Let's click on the solution that we can see. I also wonder if I already solved this before, to be honest. Oh no, I have to look. I don't care about the video solution though. Okay. Brute force n square is too slow. Wow, this is lagging my computer. But 2 pointers. There is a 2 pointers? Huh. Wow, I really did make this way too complicated then. What is the 2 pointers approach? Okay. Height of the shorter line, I know, okay. Move the pointer to the shorter line toward the other by 1 step. So yeah, you have 2 steps. The shorter. So you greedily move the shorter? I mean, I get what they're saying, and I suppose they proved it, but I don't know how to prove this off my head, and also in like 10 minutes or whatever. Like, I'm reading this and I go, okay, if you say so, but the proof for me is not that trivial. Like I don't know if I could prove this easily, and I don't know if I could explain to you in a way that is trivial. I mean, this code looks like it makes sense when they said it, but I don't, like I said, I don't think I understand the proof enough to be able to be like, hey, it's obviously this. but you know, I don't know. Have I done this before? No, I have not. So okay, um, okay. Surprised I haven't done this before, but huh. Yeah, I don't know. I don't know that I buy the of n algo. I mean, obviously it's correct. It's just that I don't know if I could figure out how to prove it. So I did this n log n solution. Let me know what you think. Let me know what how if you have a great proof on the linear time solution, that's great too. But I feel like for me at least, I did okay. It's just that's the thing with greedy algorithms is that it's like you could be correct. It's just that in my the proof is hard, right? And you have to convince others, and you have to convince the interviewers, and I don't think that's as straightforward. But that said, so that's why I like my code a little bit, because I think the greedy here makes more sense at least. But yeah, let me know what you think. Hit the like button, subscribe button. I'll see you tomorrow. Take care of yourself. Take care of others. Be good. Stay healthy. To good mental health. And I'll see you tomorrow. Bye bye.